I'd like to welcome you all to the September RWG meeting. I'm going to hand it over to Ilyes from the Reuse company. They're going to go over how they're implementing some of the latest concepts regarding the Guide to Writing Requirements 4.0 that came out.
Thank you everyone for joining. I'm Ilyes Yousfi from the Reuse company. Today's topic will be the improvement of the INCOSE Guide to Writing Requirements version 4. I will focus on some of the major improvements that were brought to the guide. So I'm not going to do a summary of all the guides, and that's not the purpose of this session. Before I get into the topic, I will briefly introduce the Reuse company and myself, and then we'll get into the improvements that we'll be covering in this talk. And then I'll get into the updated rules and new rules that have been introduced in this version of the guide. A focus on Appendix C, requirement patterns that help authoring requirements. And then this rule applicability matrix that is featured on Appendix D, which purpose is to guide readers of the guide in their choice of adopting some of the rules in the guide. And then finally, we'll go through some examples during a short demo at the end, and we'll have some time for questions and answers after that. Let's first introduce the Reuse company. So I'll briefly get into the features here. So we started the activity about 25 years ago here in Madrid as a spin-off of a university next to the offices here. We've been combining along the years systems and software engineering practices, which guided us to join INCOSE and become some of us active members of INCOSE and especially of the Requirements Working Group. We're still headquartered in Madrid with some international offices. And if I would sum up the purpose, let's say the mission, is to promote reusable solutions towards smart and complex systems engineering environments by offering a knowledge-centric approach, or data-centric as we might call it sometimes. Some of these concepts of knowledge-centric approach will be covered in what I call a data dictionary and the need for data dictionaries in requirements verification or needs verification. Most of the people that already know us for some time learned that we are called TRC, so the Reuse company, and each letter with this trick of the Q for quality in Spanish is spelled with a C. These are the main pillars that have been supporting our activities for many years. And now we've been expanding to other worlds or other fields, I would say. So apart from having quality assessment, which will be the focus of today's presentation, we will have other aspects covered, such as traceability, the interoperability aspect, the connectivity of different sources, of heterogeneous sources throughout the system lifecycle, or requirements engineering, lifecycle management, and the pillar that supports all these activities is this data-centric approach, which is the knowledge management. If I sum up basically the methodology that we're specialized in, it's the application of semantic technologies and artificial intelligence to digitalize systems engineering activities throughout the lifecycle. And one of them is the requirements verification, which is one of the purposes of the Guide to Writing Requirements that we'll be covering here in this talk. I would like to introduce the INCOSE Guide to Writing Requirements shortly for those who may not be familiar with the guide or just want to have a refresher about the purpose of the guide. So this guide has been developed by the INCOSE Requirements Working Group. One of the goals, I would say, is to provide a guidance on how to express well-formed textual needs and requirements expressions. It features a set of characteristics which derive into rules to write well-formed needs and requirement statements. And when we add attributes to those statements, we get what we call needs or requirements expressions. That's the reference that most of the system engineers will be using. And we'll see later in the presentation that there's often a debate about how extended should the application of the guide be. So we'll see later what's the approach we have about applying these rules. But here, just to sum up what happens in version 4 here. So there has been one added characteristic, which is the correctness of sets of needs and requirements. Some of the rules to characteristic relationships here have changed, but I'm not going to get into the details of the changes here. And 3 more attributes have been added here in this version. If you'd like to get more insight into this new version of the guide and check some more details, there's been some updates given during the IS 2023 meeting. And now I will focus on these 3 main improvements in the guide. First, some rules that have been updated. So rule number 6 and rule 33. I would say sometimes there's a dead angle in the rules. The way the interpretation of the rules sometimes is partial, and when we are looking at implementing the rule, sometimes we see that maybe we need some extra quality check. The challenge that we've been identifying, which is also featured in section 1.8 of the guide, is that digital assistants, which are meant to guide system engineers in writing well-formed requirements, should be able to address both needs and requirement statements, and also understand the differences between the two. So that means the takeaway we had from this statement here is that we should be able to apply a different set of rules for needs and requirements, which was the genesis of the rule applicability matrix here. About the updates of the rules, first of all, the rule number 6 enforces the use of common units of measure. This rule has already been implemented in the previous version of the guide that was released in 2019. And we've been implementing this rule number 6 in our tools. The only thing is there's one, as I said, dead angle that was not considered here, which is the consistency of the triplet component property measurement unit. So when the rule says that we have to use consistent measurement unit systems and also consistent units of measures, here it kind of means that, okay, if I'm talking about a volume, I should use the same unit. But the real thing is, depending on the component, depending on the scale of the component, depending on the standards and practices that each industry might have for given components, we might tolerate different measurement units for the same property. Here I illustrated this new feature of the rule with some examples. So if I have some requirements here with properties and measurement units, this fuel tank volume could be expressed in liters. So here I used a metric system example. It could be the same with everything with the imperial system. The only thing is, it's also another aspect here, common measurement unit system, which is important. If we have this triplet here, we don't accept this here. So the same property cannot have another unit in the same specification or in a group of specifications. But if we have another requirement using the same unit, of course, we allow that. And finally, if we have another property, another volume, we might allow that. This unit might be different. So it's not about applying exactly the same unit for volumes, the same unit for weights, etc. It's about considering the triplet here. So that's one of the new features of rule number 6. And rule number 33 about tolerances also considered here the consistency of the format for tolerances. So since this rule is considering that we have to express values that are not just absolute values, because sometimes it's hard to verify, we have to express measurement units with properties with tolerances. So the consistency in the format means that we have to avoid using one format and then another. So we have to set a convention for the tolerance values and also avoid too big or too small ranges as well. So that's also covered in the implementation that we're providing of the guide to writing requirements. There are also some variations. So do we express all the units here in each of the boundaries, or do we just allow one for all? So there are some variations here. And also sometimes we would prefer a textual format instead of the numerical one, depending on the readers or the convention we choose. So all these aspects have to be taken into account when we apply this rule. So when we have to compare something that is different, sometimes it's hard to get the real message. So we have to read that and understand it without any ambiguity. And finally, this new rule about decimal format is the new rule that has been added in this version. So this is a completely new content. It deals with the consistent format and symbols for decimals and also for the thousands. This is usually something that is related to working with multicultural teams with different countries, in which we have different standards for separating the thousands and also separating the decimals. In any case, we have to set a convention. So we've talked about the data dictionaries, which are, let's say, mostly involved convention in evaluating and verifying requirements. But sometimes we have to decide about these kind of conventions as well. In this case, if we choose commas to separate thousands, we have to choose points for the decimals and the other way around. So these are the two options that we have. We cannot mix both of them, and everyone has to know which convention to use. So it might have happened sometimes that you got an Excel sheet with one convention, and when you open it the other way, it's not recognized as a number. So that's more or less the same idea here. And if you consider this specific case of numbers between -1 and 1, in that case, we have to avoid, especially when there's a comma used for the decimals, avoid not putting the 0 in front of it, because especially when you use commas, it could be, from the reader's approach, hard to distinguish if it's 0,99 or if it's just something before that is like an enumeration or something. Like the 0 could be something we might have missed. So if we don't know that this is the convention, we might get an ambiguity here. So it's better to avoid that. So the other major contribution here in this version of the guide is the requirements patterns. And since the guide is meant to provide guidance in different domains, these patterns also are meant to be generic. So the structure is generic. The content of each slot of the structure will be based on the data dictionary that we use for the project. So I'll get to that in a few slides with an example. Just for the recap here, some benefits of using requirements patterns. The first thing is that it sets an internal standard for well-formed requirements. So if we follow the structure, it's less likely for the writer to introduce like vague terms or open-ended clauses, because we have a restriction in the sequence of words. That's avoiding some basic errors, let's say, in the requirements. It also helps, from the reader's perspective, identify keywords. So we know the subject is always featured before the shell. Here the subject is the generic category here is called agent. So it could be a user, a function, any stakeholder, of course a component. And like this, we can easily identify the subject here. And this is customizable. So as I said, it's provided as a cross-domain reference. Then we can customize the content of each of the blocks here. And that's how we build what we call pattern libraries. So each pattern can be customized to provide different requirements types. So one of the benefits of the patterns is also to identify different requirements types, like functional requirements, non-functional requirements, and so on. So in the example of functional requirements, if we look closer here to some of the examples here, I could say that my condition keyword could be any of the when, where, while, if. Sometimes where is not accepted, depending on the conventions or standards that we use. Then we have a condition, entity is, and the verb, entity is, verb, and preposition entity. So some of the slots in each boilerplate might be optional. So that's making the pattern flexible and applicable in different situations. Some of these slots can also be optional. For example, conditions, what we usually call ubiquitous requirements, don't feature any condition, and we could start the sentence with the agent. If I show an example here, basically I would say, okay, the condition keyword is while, then the condition is the system is available. We could have combination of conditions. It could be the system is available and a value number x equals or is lower than something. Then we have the agent, shall, an action, which is defined by a verb and some object. So the data dictionary here could help add another restriction, which is that we have to define what is information data. And then as defined in the user manual is a qualifying clause. And the constraint is usually a time constraint within 5 minutes in this case. And if we look at the importance of having a data dictionary in the condition, the agent is something that would be defined in an ontology or a glossary in general. So we've classified all the terms that would be qualified as agents. So it could be a system, it could be a user, it could be anything else. In that case, I'm using components and the system. The state could be something that we could pull from a model. So data dictionaries, if they are in the form of ontologies, have the ability to connect to external sources like models, like other textual sources. And that's how we can extend the content of this ontology or data dictionary for the project. So we get this from both sides. So native content in the database and some extra content that could be pulled from external sources, like multiple models, for example. And if we look at some examples matching this part of the pattern of the condition, you could have control system in ready mode, temperature water in combat mode, or information visualization system in configuration mode. So basically, this restricts even more the application of the pattern. So it's not only about following the structure, it's also about using the right terminology within the structures. We have a two-in-one here using these two concepts, the patterns and the data dictionary. And so now I move to one of the main improvements here in the guide, which is a totally different approach to needs and requirements verification rules. Because as I said, section 1.8 proposes us a challenge, which is to distinguish between needs and requirements. And that's what was intended here. So there's been work here to identify some optional and recommended rules for needs. So something that we might consider optional when drafting needs, but then considering them compulsory in requirements writing, requirements definition. Everything here is linked to the need for tailoring. So we have here a tailoring guide that we drafted for version 3, which will be updated for this new version, including the new rules and the metrics associated with these new rules. And basically, this means that we have 3 dimensions to decide how to tailor the rules of the guide to writing requirements. The first one is the level of detail. So the more specific the document is, the more domain specific it is, and the more information it will require from the data dictionary, and therefore the more rules it will assess to verify the requirements. The life cycle stage here is also important. The more we get into design input, so requirements and design input, the more we need the statements to be precise, accurate, non-ambiguous, etc. And the level of criticality. So we will not assess requirements the same way for entertainment systems than for fire detection systems, for example. So we have 3 dimensions here. And then the level of detail will help us decide whether we need or not a project data dictionary. So it's perfectly okay to start assessing the requirements only with cross-domain content, so only checking the syntax, not checking what is the terminology we use, but then we have to make sure that we have a consistent terminology, we avoid unknown acronyms, and so on. The first thing we had to look at when facing this challenge of distinguishing needs and requirements is what is the main difference? And the main difference is first that obviously we don't include the same content in needs and requirements. So since we are not describing the same thing, we won't apply the same rules. That's one pretty straightforward situation. But then this means that the rules that we will apply here will be different. So if this is different, basically this is the hypothesis. If this is different, since everything is related in this entity relationship diagram, we should get to different rules in the verification. And so that's where the tailoring is important. So we have different purposes. Needs help us check that we meet the business expectations, so validation, and requirements that we have the right features to achieve the needs. And since requirements translate needs, we have a common ground here. So the rules that will apply to needs will also apply to requirements. So we are not applying something else. We're just increasing the thoroughness of the verification. Sometimes you might have one need deriving into more than one requirement. So the relationship is not one-to-one. Therefore, we have to choose which rule that would apply to the requirements that would not apply to the needs. And that's the result of the rule applicability matrix. Here, I'm just showing some examples to help you apprehend the rule applicability matrix and know how to read it. So we have 3 categories here of rule applicability, which is the first dimension. The other one is the need for data dictionary. The first one is compulsory for needs and requirements. So this is the rule that will be applied to everything. So a rule that is considered a must in needs and requirements verification. So we cannot get past this rule because it might threaten the overall quality of the specification. Some rules might be recommended for needs. So in this case, we consider that some rules might be too strict when drafting a set of needs, and we don't want to slow down the process of stakeholder needs definition. So sometimes we would loosen a little bit the quality statement, the quality assessment, and then apply some more rules in requirements definition. So Our approach is always to foster a progressive approach in the way we assess the requirements. So starting with a small set of rules and then increasing. And with this applicability matrix, you'll see later that we have different levels of quality assessment that we can choose, starting from needs and the cross-domain content to the highest, which is requirements. So a more thorough assessment, and also applying domain-specific rules. So the other dimension is applying or not data dictionaries to assess the rule. So in this example here, the first rules were rule number 1, rule number 2. Rule number 1 is about the sentence structure. So it's mandatory, considered mandatory for both needs and requirements. So we cannot have a sentence that is not complete. We should have a subject, verb, and object at least. And this rule doesn't require any project data dictionary. It's universal, and we should apply it regardless of the vocabulary. The second one, active voice, is something that we usually recommend to apply right from the start when drafting needs statements. It's considered recommended here in that case because we have a higher tolerance when defining needs, and most of the needs would start with the user shall be notified by blah, blah, blah. So that means we have a higher chance of getting a passive voice. So maybe we don't want that to slow down the process of drafting needs. But then when we derive that to requirements, we need the quality check to be more thorough. In this example, rule number 1, as I said, is both needs and requirements, that we need the standardized structure, and in the use of active voice, needs might use the passive voice. So in this example, we have rule number 2 featured. So when invited to enter user credentials, we have the be notified. We have the indefinite article, a large screen. We don't define what it means. We define it between brackets, so it's not allowed by rule 21. But in that case, it would be considered a valid need, but not a valid requirement, because we don't define the dimensions of the screen. Maybe if we don't have the management system defined, we would have data dictionaries also involved. In that case, we can see that in this example, if we get the help from the tool, we would get these metrics involved. But if we apply the same requirement, we apply rules adapted to need statements, the result will be high quality. So the idea is to guide the users to the right amount of rules to be assessed. So this progressive approach that we foster here. So we start with white belt metrics, like in martial arts, and then we increase the level with the same specification without changing anything, would reduce drastically the quality result. So we start correcting the specification, we increase the quality level, and then we get to the next level and we increase again. And that's how we get to the maximum quality level. Because if we get too many information of low quality, it's very hard to rewrite the requirement because we don't even know how to start. If we have only a few rules popping up on the window, it's easier to rephrase the requirement and reach the high quality. So that's also another reason why we do it that way. And the more we get into advanced quality checking, the more we require the data dictionaries. Also in the life cycle, in the process of defining and finally verifying and validating the requirements, we have different options. So at the very beginning, we could tolerate some expressions that we don't tolerate at the end. And the iteration here is also part of the progressive approach that I just mentioned. With regards to the implementation, what we did is, apart from the 3 related concepts here, the characteristics, rules, and attributes in the guide, we provide an implementation that takes into account the metrics. So each rule can be mapped to 1 or more metrics. So that's the rule to metric mapping that we provide. So if you need more information about this, you can just contact us. I'll show my email information at the end of the presentation. And each metric, which basically answers the question, how should you measure the rule? Each metric provides a quality function, which converts this calculation into a 3-level rating, high, medium, low. And so this indicator needs some parameters, and most of the parameters we define here rely on the project data dictionary. Define terms and acronyms, main terms and synonyms. If you have to disambiguate 2 acronyms which have different meanings, one of them could be a forbidden acronym, the other one could be a valid acronym, so we have to configure the difference here. Any taxonomy and the relationship tree between different terms. So everything that is configurable in the data dictionary will provide intelligence to the metrics. And now about the implementation of this rule applicability matrix. Basically, we start with the first axis, which is needs and requirements. So we move from needs to requirements, and we move also from cross-domain to domain-specific. Of course, we're not starting in completely cross-domain content. The requirements by nature are domain-specific, but we have to slowly get to a higher level of data dictionary content and completion. So that's why we start with a set of rules for needs. So we start needs verification with what would be the white belt here. If we get back to the example that I previously showed, then we move to blue belt. Yellow belt would be this one. So needs with cross-domain content are very basic, but then when we add domain-specific metrics, it gets more advanced. Requirements without domain-specific content are more advanced than the needs, but they still need some extra content to have a more strict checking. And then with the final level would be this one. So this is a framework that we provide. This doesn't mean that you only need two sets of rules. You could have just one, you could have three. The main message here is that this is customizable. So in that case, the framework is you get these 4 sets of quality metrics, these templates that can be reused in different projects. And if you check the content here, you can see that, okay, you have the rule number with the category and a numbering, an ID for each metric to help you identify them. So basically, depending on the quality level that you choose, you will have more metrics assessing the quality. So that's the purpose of having these metrics implemented. And in this case, it's cross-domain metrics checking requirement statements. So 38 metrics implementing the 42 rules. So some of them are not applied because they're domain specific, and some rules have more than one metric. So you have like the rule to metric relationship here. Some facts about the project data dictionary. So I presented a talk about project data dictionaries and their application in systems engineering projects in the IWE meeting in January. First, some definitions here that are important. So the use of centralized information, common vocabulary, consistency. So the first reason we use project data dictionaries is to make sure we all speak the same language. Not by language, we don't mean, of course, English or German or Italian or French, but we use the same vocabulary to mean the same things. So consistent wording. And this, it allows to extend the coverage of the rules, as we just mentioned. So various rules require the dictionary to be assessed. And also it's helping in the standardized way of drafting requirements because it's fueling the patterns that I mentioned before. And this is what also sets the foundations for the higher level of assets that we need in organizations, which is knowledge. So we need these project data dictionaries to convert into valuable knowledge for the organization. This is just an example about defining conventions and project data dictionaries. So it's not just about wording, it's also about conventions and formats. So as I said, for the decimal format, so if you use dates, you have to make sure that you have the same format. This happens usually with cross-country projects between Europe and North America, for example, between Europe and Asia. So you have different formats. You have to make sure you use the right one and you don't get to inconsistency. Acronyms as well. So this is the same thing, but if you speak to a native speaker of different languages, of course, this have a different meaning. Of course, this is exaggerated to explain the concept here, but it's just to imagine how this simple example could get if introduced that in complex systems. So the acronym here is well known, is simple, but if we get into specific projects, if we don't make sure that the acronym is understood the same way and is not translated, we might get into big trouble in projects. And here, some examples using data dictionaries. So if we use an unknown word, it will be flagged by different rules. It's an invalid subject. It's not a defined term. It's not a defined acronym, and it's a misspelled word. So everything sums up here. So you get different issues solved using the real-time quality checking, such as shown here. If we look at this example, we can also check the definition. For example, the other advantage of using data dictionaries is that you can introduce here a definition that will help the user understand the meaning and also provide this definition to users to get the input in real time. Here, this helps increases the understanding of the content and also reduces the ambiguity. And now I will show you 3 use cases. Here, the first one, an assessment of quality using needs verification rule set for stakeholder needs, then using for the same document requirements quality rules to see the difference. And finally, how to use data dictionaries and patterns to author a requirement. So first, if we get into an Excel sheet of stakeholder needs, you'll see that this framework that I showed before is the first thing we have to decide. So as I said, this is customizable. Each quality belt is customizable, and you can end up with less or more than that. So it's providing you a framework that you can customize. You can customize the number of rules you have here, of rule sets, and also each of them in the content. So enable or disable some of the rules. So some organizations have different ways to apply these guidelines. We assess the quality of this worksheet. So you see that for the 65, 66 requirements, it doesn't last long. So you can imagine that for higher numbers, it wouldn't take that long as well. So it would take a short time. But the value is that you get a ranking of the most frequent errors. The important thing here is to check the overall results. We get 74%. We can save a snapshot of the quality. The exercise is just to compare what happens with this same worksheet if we apply a more thorough rule set, which is the rule set for requirement statements. I'm using here cross-domain metrics. So we're mainly checking syntax issues. So here, since we apply another configuration, we have to run another assessment. So that's part of the things that people that use the tools know. So the quality can be stored using these snapshots, or it can be saved back to your source tool. In this case, it's Excel. It could be any of the tools that we can connect in the tools, over 50 tools right now as of today. And now we can see that just by applying these more thorough rule set, we get a lower overall quality of the document. So let's check an example. If we open this object here, we can start looking at the different errors. So rule number 9, open-ended clauses, and the solution. So if we don't state the solution, we stay neutral in the way we express the requirement. We don't specify why or how, we specify what. It is considered an open-ended clause derived from the including, but not limited to, any of these expressions that just say we include something are not closing the scope. So that's one of the errors that we detect here. And so then once we finish this editing, we can move to use case number 2, which is authoring a new requirement here in Doors. So here, just so you can check, this rich authoring plugin is embedded within Doors. So it's exactly the same window that we saw before, except that it's interacting directly with Doors. We have different versions of this plugin, including a web-based extension for those using web-based ALM, PLM solutions. So here, if we start drafting this requirement, you see the importance of the data dictionary. So each slot is to be filled in with specific words that are defined as such in the vocabulary. So you can check the definition, to which groups of terms, what we call clusters here, it belongs, any translation of the word, etc. And you can see the progress of your pattern and what other term is expected. So you can pre-type as well, and the pattern will tell you if it's matching or not. So if it's not matching, you get a red color, and you have to delete the last term and try to fit into the pattern until you get to the end of the pattern, and you get the green color. Whereas the yellow one means it's on the way. So here you have a missing unit, and once you put the unit, in this case, I don't enforce tolerances, then I get a high quality and I can save this object. So that's the interaction we have with Doors. And then we can also scroll up and edit an existing requirement, check the rule set, what it says. In that case, we get more errors. You can disable the pattern-based writing, because here you probably just correct some words. So we have unclassified terms. This is telling you that it's not belonging to the data dictionary. Here we have synonyms. So it detects that utilize is a synonym. It offers you to replace utilize by use. So once you do that, this error disappears. You have an at least, which is an open-ended clause again. And then you get going and you get reduced the number of mistakes until you reach high quality. So the word sensor is considered a solution term. In here, it's telling you have to use something to measure the physical environment temperature. What we need to know is that we shall measure the physical environment temperature. We can put the solution maybe as a suggestion in a rationale or any other attribute, but this needs to be out of the requirement description. And then again, we have another word which is a synonym. If you consider that compute is the main word, we have to use that one instead of the synonym. And if we stay with this mistake, then we have to suggest this term to be added to the data dictionary, and someone, an administrator, would say, okay, I'm getting a term suggestion and I'm going to add it in the domain. So that's basically the workflow here. If there are any questions in the audience? I see one question here from Julian. So connectors to RVNS. Yes, we do have connector to PTC solutions, so Integrity, RVNS, which is a part of Windchill. We have a connector to RVNS. So if you'd like to get in touch and talk about the compatibility versions and so on, we can discuss that later. DNG is one of the connectors we had in our previous version. Is getting migrated, so we will have it in our next version. It's also part of the scope as well. If you have any questions or would like to get in touch to check maybe some of the features I discussed, or have a discussion about how to apply these rules to your specific activities, or how it would fit into one of your use cases, then you can just drop me an email or contact through LinkedIn as you wish, and then we can discuss that. I would like to thank you guys, Kevin, Lou, and Tammy, for giving us the opportunity to present these improvements of the guide. I hope that gave a good insight into those changes. And of course, this will come with more materials. So of course, this implementation is something that you could add to our out-of-the-box content to modify it. So it's, as I said, it's customizable. And this rule to metric mapping is also something that would be available on our website, as well as the guide to tailoring the rules, which is also something that I mentioned in this presentation. So if you have any questions, just send me an email and I'll be glad to answer your questions.
All right, and thank you for the presentation also, very insightful.